All right, so today we are going to talk about solving equations involving multiplication division. Yeah, go so fast. All right, so let's switch that out. So if you could grab a notebook if you don't have one already. I think I've got to clear a page as per usual. All right. So we're going to call this one 4-4, solving multiplication and division equations. So luckily, we already know how to solve an equation. We looked at them when we were doing adding, subtracting. So the goal is still going to be the same. I still want to get the variable by itself. And I'm still going to make that happen by doing the reverse of the operation that I see. So let's just add, we still want to get the variable alone. By doing the opposite operation. Let's say that. The multiplication ones are a little bit easier than the division ones, so we'll start with those. But division's not too bad. It just can take a little while to get used to. So we'll start off with a nice easy one. Say I had something like negative 5x equals 15. So if I'm trying to get the x all by itself, I need to get rid of this negative 5. So a lot of times, here's a mistake that kids will make. They'll try to add 5 to both sides. But you're not subtracting 5, are you? So you would only add 5 if you were subtracting 5, but I'm not. I'm multiplying by a negative 5. So what's the opposite operation of multiplication? Division. So I want to divide both sides by a negative 5. That's how I'm going to get this variable by itself. Okay, so, and just like before, whatever you do to one side, you have to do the other. So if I divide this side by a negative 5, I have to divide this side by a negative 5. Okay, so luckily on the left-hand side, those negative 5s cancel each other and I'll just be left with x. And now on the right-hand side, what is 15 divided by a negative 5? Negative 3, right. Just like before, and it's true with all equations, you can check this answer. If you go back to the original, negative 5 times negative 3, is that really positive 15? Yes, so I know that I'm right. Let me give you another one. Say you had something like 10x equals negative 40. 10x equals negative 40. So you want to get the x by itself. So you got to do the opposite of what operation is already there. So what does that mean you're gonna do? I heard the right answer. It is -4 because we are going to divide both sides by 10, right? I want to get rid of this 10. So instead of, I'm going to do the opposite. Right now I'm multiplying. So now I'm going to sneak in and I'm going to divide both sides by it. That's how I get x all by itself on the left. And on the right, I just have to do the math. -40 divided by a positive 10 and -4 in the end. And yes, you can go back and check it and it works just fine. Okay, those are the ones that are a little bit easier. Oh, let's do one with a decimal just before I forget. So say I wanted to do something like 0.3x equals 1.8, something like that. Well, just tell me what is the, how am I going to start? Yeah, I want to get this x by itself, so I need to get rid of this 0.3. So how do I do that though? What operation do I do to get rid of this? Divide, yeah, because right now it's multiplication, right? It's 0.3 times x. So I need to do the reverse operation. So I want to divide by 0.3. Divide by 0.3. Okay. So if you have a calculator and you're allowed to use one, 1.8 divided by 3. If you don't have one, or if you're not allowed to use it, you remember how to do this out by hand, right? I'm just gonna do it real quick. If I was gonna do this by hand, 0.3, 1.8. Do you remember what you do first when you have a decimal and you're trying to divide?
You move the decimal.
Exactly. So I have to move this one spot. So I move this one spot. So oh, wait, sorry. It's not gonna be 0.3 anymore. It's gonna be normal 3 divided into 18. Turns out, well, I know what that is. 3 into 18 is just 6, isn't it? So that's my answer. Okay, so how do we feel with the multiplication ones? Easy enough, you just divide both sides by whatever. Yep.
Can I see the whole thing?
Oh, yeah, sure. So,
You add a point to the 6, right?
no, you won't have to, right? Because if you move this one and you move this one, now it's just 3 into 18, so it's just 6. Okay, so let's do some division ones. They're a little bit weirder. But maybe not. I don't know. We'll see. Let's slide this up a little bit. All right, so say we had something like x divided by 4 equals 3. So again, my goal is always to get the x by itself. Right now I'm dividing it by 4. So what would the opposite operation be? I'm dividing by 4. I'm going to multiply by 4. That's all. So check out what happens when I am down here and I want to multiply by 4. Look at how this works. If I multiply this side by 4, well, remember, you have to do it to both sides because whatever you do to one side, you have to do to the other. But look what happens on the left. Those 4s cancel each other out, which is the whole point, right? Because I'm trying to get rid of it. I'm trying to get that x all by itself. So now I have x on the left, and then 3 times 4 is just 12 on the right. And you can go back and check it. Is 12 divided by 4 really 3? Yeah. So I know I have the right answer. Let's try another one. What if you had x over -7 equals 10? So I want to do, say it again.
Add 1 under the 10.
You can, but you actually don't need it. You can get away, Jay, what would you do? Yeah, so instead of dividing by 7, we're gonna multiply both sides by 7. So I'll sneak that in and, oh, -7, right? So on the left, both of those cancel, so I'm just left with x. And then on the right, I'm just doing 10 times -7, and I get that -70. Especially these easy ones, it's worth you taking the 2 seconds to check it. -70 divided by -7 really is +10. Yes, we know we did it right. Okay, does it get harder than this? Unfortunately, yeah, a little bit. Let's look at one that has some fraction action happening in it. Something like, what if you saw 3/4 x equals 12? Now, these are weird. Or are they? I don't know. Maybe it's not so weird. So can everybody pay attention to this one? Because these are easy to mess up. But once you get the hang of it, it's not so bad. Right now, this says 3/4 times x, right? So if I want to do the opposite, that means I want to divide both sides by 3/4. But when you divide by a fraction, what do you really do? Didn't we do yesterday when all that whole worksheet, right? If you remember, this whole worksheet was dividing by fractions. Didn't we do keep, change, flip? So that's exactly what we're going to do here. I do want to divide both sides by 3/4, but dividing by 3/4 is the same thing as multiplying by the fraction flipped over. So I'm actually going to put a big star here because this is important. Oh, I should have left myself a little space because I need to put something next to that 12. So I'm just going to put a big old star. Dividing by 3/4 is the same as multiplying by 4/3, the fraction flipped over. It is the exact same thing. Okay, so when I go to handle this one, instead of writing divide by 3/4, divide by 3/4, I'm going to write it as times 4/3. So let me give you a moment to finish writing that down so you can see exactly how we're handling this. Okay, you ready? So I am going to, and you know what, I'm going to move this example symbol over a little bit so I can fit everything in. All right, so I'm going to multiply both sides by my fraction flipped over, 4/3. Look what happens on the left. Look at how the 4's cancel with each other and the 3's cancel with each other. So the only thing that's left is x. And then over on the right-hand side, I can put the 12 over 1 so that they both have fractions. You can multiply straight across and reduce, or if you want to be fancy, now that we learned that we could reduce first before we multiply, just to keep our numbers smaller. So couldn't I reduce the 3 and the 12? So you know what, I'm going to see if I even have a different color. See if this purple will show up. I could reduce the 3 goes into 3 once, 3 goes into 12 4 times. So when I multiply straight across, looks like I'm getting 16 over 1 or just 16. So that's the trick with these fraction ones. You're actually going to multiply by the reciprocal, the fraction flipped over. So let's try another example. Say we wanted to do, let's do something like this. -2 equals -8/3 times x. So normally I'd come in here and I would divide both sides by -8/3, right? Because that's, I want to get rid of this and I'm multiplying. So I would normally come in and divide. But dividing by a fraction, as we just talked about it, is the same thing as multiplying both sides by what? What should I multiply both sides by to make this work?
3.
Yes, I'm going to multiply both sides by a 3/8. And I'm going to -3/8, right? This side, -3/8. Look what happens over here. Look at how the 8 cancels with the 8, the 3 cancels with the 3. A negative times a negative is a positive. So all I'm left with on the right-hand side this time is x. And that's what's supposed to happen. I'm supposed to get the variable all by itself. That's the whole point of why I did it like this. So all of these should cancel with each other. Now over here, I just have to do the math. A negative times a negative is going to get me a positive, right? I can put 2/1, multiply straight across. That gets me 6/8. I can reduce that down though. What does 6/8 become? 3/4, perfect. And we already said that it was positive, so we're done. They are weird, I grant you that. Okay, so why don't we, you know what, let me just do one more example because I don't want this to mess you up later. When you see something like this,
We have our quiz or test on Monday or Tuesday.
I don't think it'll be Monday anymore. I think we should practice this more. But I just want to show you this. If you saw something like this, -x/3 equals 6, whatever. So when you have a negative in a fraction, did you know that you can move that negative sign? It can move. You normally, yes, we put it up in the numerator, but you can move it down to the denominator if you wanted, as long as it stays somewhere. So it doesn't matter if you attach it to the top number or the bottom number. So what you could do, you could multiply both sides by 3, but then you still have a -x, and then you could just divide both sides by the -1 and you can get there. Or if you wanted, you could just move this negative downstairs and call it x/-3 instead. And now I can multiply both sides by -3 and it would just take care of itself, right? So if I multiply this side by -3 and this side by -3, those just cancel and I'm just left with a positive x over here on this left-hand side. And then over here, I just get a -18. Oh, I'm sorry. I didn't realize I was off. There we go. Ah, worse. Sorry. Okay, so you are allowed to move negatives in fractions. We usually just put them upstairs all the time, up in the numerator, but they don't have to be there. Okay, so I'm going to give you a very, very brief homework assignment, which you can finish before you leave. On Monday, we will practice some more. I probably won't. I don't think we'll have the quiz on Monday, unless you want it. I don't know. I guess we'll see how. I have it ready to go, so whenever you're ready, we can take it. So if you want it Monday, we can do it Monday after we review a little bit, or if you prefer Tuesday, we'll go to Tuesday. That's fine. So let me give you your brief homework assignment, which is really classwork. And then we'll go from there. Questions? Is everybody okay so far? Yeah, all right, so let's see, how about on this? How about we just do the multiples of 3? So that's 3, 6, 9. Only goes up to 24, so that's not that many. Okay, so just the multiples of 3, starting with 3.